Okay guys, this is the last part of how to graph a linear equation. We talked about the t-chart method. Now we're going to do my favorite method, and that is graphing using slope-intercept form. I think it's the easiest and quickest way. So let's get right into it. Method 2, slope-intercept form. Slope-intercept form is based on changing the linear equation to the form y equals mx plus b. So the first step is to see if the y is isolated, if the y is by itself. If the y is not isolated in the equation, you need to solve for y to get it in slope-intercept form. You need to get that y by itself. And by doing that, what you have done is you have created the m and the b, which is the slope and the y-intercept, so that you can graph very easily. So after you get it in y-intercept form or slope-intercept form, you need to plot the y-intercept. Now the y-intercept is located on the vertical axis, so it will be a number, and you plot that point right on the y-intercept, and then you use the slope to find other points. So starting with the y-intercept, you're going to use your slope, your rise over your run, to either go up and to the right or down and to the right, and vice versa, whatever way the slope tells you to go. Okay, then of course after you get several points, 2 points make a line, but the more you have, the better off you are. You draw the line, and that's how you do it. It's fairly easy. Here's an example. This example looks very familiar to you because it's the exact same equation that I used for example 1. This time we're gonna graph it using a different method. We're gonna graph it using slope-intercept form. So the first step says get y by itself. Well, in this case, y is already isolated, so there's no work. Basically, we go straight to the graph and we start plotting. Just remember that the slope is 1/2 and the y-intercept is 3. And I have this on a graph here for you that I want to show you how to do. Alright, so here's our graph, and on this graph, I created this graph off of Desmos, the calculator that I showed you in the previous video. And I exported it and put it right in my PowerPoint here. Alright, so the blue line is the linear equation. Should match what you have from example 1, but here's the steps. First of all, I plotted 0, 3, which is the y-intercept. mx plus b. B is the y-intercept, and b is 3 in this case. So I went up to 3 and I put a point. Then I used the slope. The slope is positive over positive, which means you're going to go up and to the right. Positive, up, right, positive. Okay, so in this case you go up 1, you rise 1, and you run 2, or run to the right 2. Up and to the right, up and to the right. Okay. It's also important to understand that up and to the right, if you flip both of those, you get the same relationship. So in this case, positive over positive is the same thing as negative over negative. So up and to the right is the same thing as down and to the left, and down and to the left. And you see with this method, I can plot points very, very easily. Okay, that's it. That's how you plot. Okay, let's look at the next one. Example 4. Looks familiar because example 4 is the same as example 2. This time we have 2x plus 3y equals negative 12. Okay, instead of doing a t-chart where we have all the work, all the computations, getting all the points, we're doing a slope-intercept form. So first step is to isolate the y. The y is not by itself, so we have to do a little bit of work. Now, hopefully you will show your work on your graphic organizer a little bit better than I did here. It's kind of hard to type up all the steps, but I do show you or tell you in parentheses here what the idea is. So the first thing is I want to get rid of the 2x and move it over to the other side, and I'm going to subtract it. And when I subtract it, you got to do whatever you do to one side, you must do to the other. And I want to put it in the front, okay, because we're trying to get it in mx plus b. So I know the x part needs to come first, okay. So the next step after you subtract the 2x is we got to get rid of the 3, and it's attached by multiplication, so you must divide. Whatever you do to one side, you must do to the other. And I'm going to divide all the parts out, so this will be negative 2 over 3. And then negative 12 divided by 3 becomes negative 4. So y equals negative 2/3 x minus 4. Slope is negative 2/3. Y-intercept is negative 4. We're ready to graph. Okay, here's the graph. Again, copy the image from that online graphing calculator. I got the equation here just to show you that this is our original and this is what we adapted to get it in slope-intercept form. These are the exact same equations, that just look different. First step is to plot the y-intercept, so 0, -4 is down this way. And the slope is -2, 3. Now, negative rise, which will actually be go down 2, and then you're going to run 3, and then down 2, run 3, and plot your points that way. Opposite of down and to the right would be up and to the left, up and to the left. So just by that method right there, I plotted 5 points, and you can see my line very easily. Now, what you may want to do is you may want to pick one of these points and check it. For instance, this point right here is -6, 0, which means the x is -6 and the y value is 0. So if I plug those in, -6 for x, I get -6 times 2 is -12. And then 3 times the y, which was 0, is going to be 0. So -12 plus 0 is equal to -12. So I know that that point does work. And I could check any of these other points on here as well. So to sum it up, we have two methods. The T-chart method, which you plug in your inputs, get your outputs, and plot your points. And then we also have the slope-intercept form method, which you need to adapt the linear equation to y = mx + b and plot your y-intercept and use your slope.